Hi students, welcome back to Doshit Sir's Maths class. Today we are going to start lecture number 6 of chapter number 1. In lecture number 5 we have studied how to find the square roots of root 2 and root 3. Now with the same topic, here we will find the square root of the other numbers. The numbers which are greater than 2 and 3. So, how to find square root of the numbers on the number line? So there are the few steps you need to follow. Draw a number line with only whole numbers. So your first aim is to draw a number line with only whole numbers. Your question comes, why only whole numbers? Because as you take any root of any of the numbers, you will always find a whole number only as the answer. Square root of any number cannot generate negatives. This is the reason we are only occupying the whole numbers on the number line. Take the baseline of the nearest least perfect squares and its square root. And now what are the perfect square numbers? Perfect square numbers are the numbers whose square root is a whole number, like 4, 25, 9, 16, 100. These are the numbers whose perfect squares, because their square roots are whole numbers. Increase the spirals of 1 centimeter perpendicular line segments to the new baseline till required number comes. What it is exactly, I'll show you with the constructional part. So how root 5 can be written? First of all, 5 can be written in the form of 4 plus 1. Why is it so? Because 4 is the nearest least perfect square to 5. So that's why I am taking 4. But whenever two numbers comes like this, you need to write both of them into the square root and you need to take the square of that. That is what we have learned from the last lecture, Pythagoras theorem. So we are going to take the same way root 4 square root and its square, because we know that square and square root is going to cancel. So we are not doing anything, just we are following the Pythagoras theorem's fundamental reason. So this is square root of 4 square plus 1 square. What is square root of 4? Square root of 4 is 2. So that's why it is 2 square plus 1 square. Now this number decides the length of the baseline. So what should be the length of the baseline? Length of the baseline should be 2, this number. And this decides that how many spirals do we need to add. So this number is also equally important. First number decides length of the baseline, whereas the second number decides that how many spirals we need to add to find this. So this was the calculation part of the question in which we are finding root 5. Now we are going to the constructional part. So constructional part, as you have seen in the steps, your first aim is to draw the baseline, which is the number line. So the number line, specifically at 1 centimeter distance, every number should be kept. 0, I am naming it at origin. As you have seen the length of the baseline, so the simplest way in which you can find the answer is you take that as a baseline. There is one more way in which you find number of spirals by taking 1 as the baseline only. Like 1 as the baseline, the first spiral gives you root 2, then root 3, then root 4, then root 5. So in that case you need to add 4 spirals after getting root 1 as the baseline. But I am giving you a simpler way in which you just have to find 1 spiral by taking the nearest least perfect square number to the number we are finding. So here it is 2, as we have mentioned over there. So 2 is the baseline, I am naming it as A. There I am taking a perpendicular line using protector, which is again of 1 centimeter, which you know from the last lecture that always the perpendicular line need to be taken as 1 centimeter only. Then I am joining OB, which is going to be the length of root 5. Using again Pythagoras theorem, hypotenuse is going to be root 5 if we follow this pattern. Then OB is root 5 now, but OB is not on the number line, but we want the number on the number line. So as previously we have done, we have to use protector, where we will keep the pointed end on the origin always, and we will take the arc by keeping pencil end on B, and just we will draw one arc from it. So where the arc intersects the number line, we will find root 5 at that particular point. So that particular point I have named as M, which is showing root 5. So now I can claim OB is equal to OM is equal to root 5. So this was how you can find root 5 on the number line using a simple method